With the Water Environment Federation. I want to welcome each of you to the Chemical Grouting webcast, Control Infiltration and Sustain Existing Sewer Collection System Assets, sponsored by NASCO with the support of ICGA. Before we begin, I would like to quickly review a few logistics. All of the PDF PowerPoint presentations are available for downloading at WEF's FTP link. This link was distributed via email yesterday and will be distributed again tomorrow for anyone that registered after the time of distribution. The FTP link for this webcast also has information on how to receive professional development hours for those eligible to receive these training credits. There are 2 PDH credits for this webcast. You will need to complete the evaluation form to receive the PDH certificate. Your feedback on this webcast is important and helps identify future webcast topics that are timely and helpful to you. Please follow the PDH instructions and check with your state accreditation agency on how to receive this credit. During this webcast, while you cannot speak directly to the presenters, you will, however, have an opportunity to submit questions by typing in your specific question via the pane that appears on your PC. Today's moderator, John Nelson, will be accumulating questions and direct them to presenters throughout the webcast. We will be recording this webcast. A link will be sent to all registered users tomorrow so that you can share with other colleagues who could not attend this webcast. If you have any additional questions after the webcast has ended, please email webcast with an S at wef.org. I would first like to introduce today's sponsor representative, Ted DeBoda. Ted is going to talk a little bit about NASCO and ICGA and then introduce our moderator. Ted is the Executive Director at NASCO. Ted?
Thanks, Rebecca. I want to take a few minutes to introduce NASCO and the ICGA who are bringing you this webcast. NASCO's one goal over the past 35 years has been to improve the success rate of everyone involved in the pipeline rehabilitation industry. ICGA is a division of NASCO, and their mission is to support and promote the proper use of chemical grouting as a safe, economical, and effective means to reduce groundwater infiltration into sewer collection systems. Since you're on this webcast, you can see how ICGA's goal supports NASCO's goal. The ICGA and its members are a valuable resource for anyone trying to control infiltration. On their website, sewergrouting.com, you can find training, specifications, technical references, and contacts for networking and technical advice, and actually many of the people that you'll hear today on this presentation. After the webcast, I'm going to be providing you with some more information and telling you how to tap into these valuable resources provided by the Infiltration Control Grouting Association. Your monitor this afternoon will be John Nelson. John has over 29 years of experience in the trenchless industry. He attended Ohio State University and is well respected in the industry. He's also well versed in collection system inspection, maintenance, and rehabilitation techniques. Currently, John's Vice President of Operations at Visusewer. He serves on the NASCO Board of Directors and is the most recent past president of NASCO. John lives in Racine, Wisconsin with his wife and 2 daughters. John?
Thank you, Ted. Appreciate the introduction. I'd like to welcome everyone to today's webcast as well. A couple other quick items to cover. We will be doing poll questions between each presenter. The poll questions are very simple to process on your individual computer screens. When those poll questions pop up, just please choose the appropriate answer, and we'll post the answer to those poll questions immediately following the question period. Today's presenters are of various experience throughout the country. I'll be handling the introduction and a brief session at the end. My name is John Nelson again. Dick Shantz will be handling a session, as well as Daniel McGill with Avani International. Mark Anktel with Logiball, and Edward Paradis with Denif Chemical Grout. So we'd like to start off with a simple question. You've got a leak, and what do you do? Many communities throughout this country are facing similar problems with leaky sewer systems. One of the problems is coming through one of 2 sources, either infiltration or inflow. Leaks in a collection system are typically categorized by their source. And these two terms, inflow and infiltration, are the primary terms used for categorizing where the leak might be coming from. Inflow is water that is directly connected to the collection system from known sources, such as manhole covers, open cleanouts, downspouts, and groundwater sump pumps. Infiltration, on the other hand, is water that is typically percolating through the soil. It enters the sewer system through the ground from pipe and manhole joints, as well as foundation drains, defects, and cracks. Here's a brief diagram where those specific items are coming from in a sewer system. You might have a specific issue where you have water entering your sewer lateral. You might have it entering from the storm sewer and infiltrating out of the storm sewer into the sanitary sewer through various defects. You might have problems in your manholes, roof leaders, items such as that. What are the effects of I&I? Well, surcharging is one of the major effects we see across the country. Typically, when sewer systems are inundated with high levels of groundwater and through various sources such as severe storms, the system will become surcharged, which then forces extenuating pressure on the system throughout the collection system. This surcharging effect that can occur at any time during these rain events tend to wash fines into the existing joints. And this, what we call almost breathing effect, that Dick Shantz will cover in more detail here shortly, can cause severe defects in the joints and in the connections themselves. Another effect of I&I is the loss of sewer capacity. Obviously, as the system starts to surcharge, there's sometimes not enough room for the existing flow. Basement backups are, again, another problem, as well as water quality issues. Here in the Wisconsin area where I currently live, we struggle with beach closings in the Great Lakes, and they are sometimes attributed to overflows and issues with surcharging systems. Voids and sinkholes, pavement failures are on the extreme side where I&I can cause problems, but they are also issues that arise from problems with surcharging and I&I issues within this collection system. And then finally, we all end up paying higher in sewer water rates because of these I&I issues, simply because we're trying to struggle with methods to remove the extra I&I in the systems. So just to kind of give a quick overview, the effects of I&I are pretty straightforward. You've got surcharging, loss of sewer capacity based on backups, decreased water quality due to overflows, voids, sinkholes, pavement failures, and higher sewer and water rates. So back to the initial question. So you have a leak. Here are some of the items you need to be identifying immediately when you find those leaks. First of all, where is it coming from? Where is it located? Is it in a manhole, or is it in a specific pipe section? How large is it? Is it a weeper, a runner, or is it a gusher? Is it related to a structural defect? That's an important question to ask, because that'll help determine the appropriate remedy or rehabilitation technique. And finally, how do you fix it? And that's what we're going to focus most of this presentation on today. Is how do we fix infiltration, and primarily infiltration, and how it enters our collection systems. With that, we'd like to fire out the first poll question to the group. It's a pretty simple question. And that question is going to be, what role do you play in this industry?
We have about 50% voted, so I'll just leave it open for a little bit. All right, it looks like the vote stopped coming in. I'll go ahead and share the results, John.
That'd be great.
Do you see the results? It's about 41% consulting engineers, 17% city-county engineers, 26% public works professionals, 6% specialty contractors, and 10% regulatory agencies.
Well, I thank everybody for participating in that poll question. Next, we want to introduce our first presenter, or I guess it would be the second presenter, Dick Shantz. Dick has a BS in Mechanical Engineering and an MBA, and spent 4 years in the U.S. Navy Civil Engineering Corps. For the past 25 years, prior to his recent retirement, he was with Aries Industries, a manufacturer of sewer, pipeline, and TV inspection equipment. He has spent his whole career working with water-related equipment, and his experience covers all aspects of business startup and management, including sales and marketing, product development, engineering, manufacturing, and field construction. 10 years ago, and with the assistance of Vani and Logiball, he started the Aries Grout Boot Camp, a training program for sewer line grout operators, inspectors, and engineers. He is now an independent consultant offering technical and training services. Dick, take it away.
Thank you, John. Hopefully I'm on screen. In this section, I'm going to be covering really extensively the storm and sewer utility pipe trench system and how these trench systems directly impact sewer infiltration. I guess there's three messages I really want to get through. One is that all trench systems are interconnected underground. One way or the other, they're interconnected. Two, all trenches drain, as you would expect, to the deepest trench, and that's usually the sewer pipe trench. And three, the trench systems are really what drives infiltration, the water outside the pipe coming in. So I encourage you, if you have anything to do with trying to control I&I, when you get to infiltration, learn your utility trench system. Well, this is how it all started. This drawing clearly shows how we put, stormwater, sewer systems, gas systems, water systems, one upon the other, laid in, interconnecting trenches all over the place as we started to build our utility infrastructure. Initially, the storm and water pipe collection systems were never designed to be watertight, and that's important. Never designed to be watertight right from the beginning. And infiltration and exfiltration flows were expected, and they really were included in the sewer early design standards. Of course, the Clean Water Act changed all this, but the first 75 years, there was no Clean Water Act. And we put a lot of pipes in the ground. You'll see it again and again. There's one thing that stands out in these pipes, it's the joints. From our homes, from our buildings, everywhere to move sewage. And of course, we had to do it with something. We needed pipes and fittings, and by 1908, there were over 70 clay tile manufacturers making their own joint systems, different dimensions, all kinds of stuff. Today, there's less than 5 manufacturers, and they all follow ASTM standards. We rapidly settled on vitrified clay pipe. It was relatively cheap, easy to make in 2 or 3 foot sections, light enough for hand installation and proven through history to be resistant to sewage, water, and gases. With good bedding, these VCP sections will last forever, but the joints, that's a whole different problem. And we put a lot of joints in. We put over 5 billion feet of pipe in the ground in the last 125 years for sewer and storm. These short 2 to 3 foot pipe sections were all connected by simple joint methods which compensated for the cast clay surface irregularities, helping to maintain alignment and provide an initial static water seal. Seal integrity was not a factor at that time. It was sewage, or it was stormwater. It could leak into the ground, no different In the outhouses, we were eliminating. And there were no required water pressure tests. In other words, there was no head test prior to the 60s, and even in later years in many states and communities. The large city sewer utilities, however, were well funded and the first to develop and enforce early construction material standards. Poured tar joints were the normal practice, and you can see from this sketch that the tar drips on the inside wall, and you can see some of these today when you survey a pipe. As you might imagine, incomplete seals must have been common, leaving gaps, air pockets, cold joints as the tar randomly flowed into the joint. Without a water head pressure acceptance test, these sealing techniques, however, were considered sufficient and the pipe was accepted. And a lot of concrete drain tile also went into the ground. Again, the seals were not really an issue. It was stormwater. It could leak into the ground. And, of course, more pipes continued to go in the ground. The pipe segments were well aligned at installation, you can see in this picture, because we used graded aggregate bedding materials. The pipes were well set. However, the bedding material porosity created an instant French drain effect in the sewer and storm pipe trenches. We built a drainage system on the outside of these pipes. These trenches continue to be the major water source driving sewer infiltration problems today. Okay, again we see the selected and graded bedding aggregate in the tar joint. Even in clay and loam soils around the country, the pipe bedding is providing a French drain, collecting and channeling future infiltration water on the outside of sewer pipes downstream toward any and every leaking sewer joint or tap connection. Both the pipe is partially buried in bedding gravel, maintaining alignment while the joint is poured. Maybe this method, if you think about it, might explain why infiltration, common at the bottom 6 o'clock position on many pipes, however, is masked by normal sewer level flows. It's not easy to identify or note it during video inspections. Very often infiltration, if it isn't flowing rapidly, is not tense.
Hey, Dick, it's Rebecca.
Yes, Rebecca.
We're just getting a few comments that people can't hear you very clearly. If you could just make sure you have your phone close to your mouth, that would be great.
Okay. Am I doing better?
Yes, that sounds good. Thank you.
Today, the municipal sewers are some of the oldest utility pipes. Here you can see a joint tangled into a complex network of often privately owned and directionally drilled modern utility networks. And here's the EPA drawing, I think dating to 1991, that many of us are familiar with, but it really started people thinking and understanding about the complex nature of our inflow and infiltration sources. You saw this in John's presentation. I'm going to go into it in greater detail. You're going to see it in later presentations. Here's an isometric cutaway of the same drawing. We've added, however, the storm and sewer trenches in the bedding material to reveal how these pipes and trenches are interconnected. The trenches are not, however, in homogeneous soil like you see here. As you can imagine, as these trenches were dug, they crossed different types of soil that could be deposited in alluvial field or in backfill, any number of reasons. So there's all kinds of sections of the underground structure, shall we say, that naturally occur that is just cut away and filled in with a pipe trench and a pipe. This diagram, first developed by Peter Keefe with ADS and presented in his article, Underground Waterfalls, clearly shows the interconnection of storm and sewer water piping. I think you can well understand this. It may not be quite the arrow effect that you want, but you notice here's a stormwater pipe almost full. Water's coming out of the joints, filling the stormwater trench. As soon as it crosses the sewer trench, bam, it drains down to the sewer trench. Okay? So gravity-driven stormwater cascades down into the lower sewer trench, ever increasing volume as the storm continues. Once in the sewer trench, This water flows downstream, infiltrating into sewer pipes at every leaking crack, service tap connection joint, and manhole. This type of migrating trench water is classified by the EPA as rain-derived I&I, or simply written RDII. Here you see, again, our drawing, this time in a pure cross-section showing the main components, typical relationship of the stormwater system over the deeper sewer system. If it had been vice versa, we would have had water draining from the sewer system into the storm system, and that has happened in some cities. Okay, the brown line is the sewer piping, and the green is really the groundwater, sort of a background, I'll call it, of potentially infiltrating water often found in the sewer pipes. If we look closely at it, you can see it here as it goes past. It's not defined as two layers here. It really mixes together. But you got the bedding. If you look at the left, you'll notice that the pipe segments, sometimes they're sort of like very sharp crescent moon sections. It looks like the pipe was not installed correctly. That's a sure sign that the pipes have shifted since the initial installation. Okay, we're back at this drawing. Using this drawing, we're going to look at the rainstorm or a major snow melting event and the sequence and see how the hydraulics of the trench water drives sewer infiltration. You've got to imagine that, picture these systems. They are not just isolated pipes. It's really the trench system. Again, the different I&I contributors are here in the upper right-hand corner. We got groundwater, we have sewage, and we have inflow. And you can see the inflow starting to come in off the roadway. You're seeing the inflow coming down the gutter drain. You see it off the grade, but it's feeding one way or the other. Once the water level in the storm and sewer pipes systems begins to rise, there is increased water head pressure. And this increased water head pressure drives exfiltration from both the sewer and sanitary system through any open cracks, joints, connections, and even a manhole, if it's surcharged, into the supporting bedding trench or the manhole structure support. As both the storm and sewer pipes become surcharged, there's an ever-increasing ebb and flow. In other words, sometimes the pressure is greater in the pipe and it goes out of the joint into the trench. Sometimes the trench water pressure is higher, it comes into the pipe. And this ebb and flow, or a breathing effect that John mentioned earlier, the water is literally moving back and forth across any of these openings. This begins to break down the bedding soil, and it emulsifies or suspends the fines in these supporting soils. These suspended particles and soil fines eventually are washed through the joints and connections into the pipe, and they become the sediment revealed during manhole and pipe TV cleaning and TV inspections. And right now, you know this, and I'll just repeat it, but loss of bedding soil fines is going to destabilize the bedding material, and as that destabilizes, the pipes begin to move. And if you get pipes moving, you're going to start to lose alignment, and that means your joints are going to break open. Remember, many of these joints are 50, 60, 70, 100 years old, made out of tar, or some of the older ones out of oakum. There's nothing left there at all. Depends on what kind of a city or the age of your city and the part of the infrastructure you're looking at. Again, I take you back to this underground waterfall sketch. You can see the draining down effect here, the same thing I just talked about. Many additional surface to underground stormwater channels or trench drains have randomly developed over the years into the storm trench and into the storm pipe. And all of these are collecting groundwater, first towards the storm system, and then the storm trench, and of course it all just percolates down whenever it has an opportunity to cross flow to a lower trench, lower head, and that's just water seeking its lowest level. As the storm continues, both the sanitary pipe and trench systems become surcharged. The increased water head drives more water into the pipe trenches and surrounding soil. It just gets worse. Okay? Now, this is a picture I want to spend a little time on. This is the intersection of the service lateral trench and the main sewer trench. In this view, you see the intersection of these two clearly means that we really just have one trench system with a bunch of legs like a great big octopus, okay? When the sewer main and trench surcharges, the lateral tap and adjacent service piping also get flooded, and vice versa. When I&I enters the lateral service pipe joints and trenches, it floods downstream into the main pipe and trench. So when you talk about rehab, you can't just say, I'm going to rehab the main. You have to see where's the water going to come back in. It's going to be at the laterals. Again, the misalignment of the joints and connections commonly seen on sewer main and lateral TV videos, and you've seen the misalignment we just talked about earlier, reveals the pipe bedding has moved or been washed, allowing these short 2 or 3 foot pipe segments. And I think you've also seen the 4, 6, 8, 9-inch lateral pipe transitions, where they come out of the main and then they jump around a little bit very often before they get lined up with a lateral service. All of that's moving. If you see this twisted offset pipe segment condition, you can expect to find seal failures in many of the older port joints. The same holds true for lateral connections of joints. If the pipes are moving, port joints are failing. The watertight integrity of the service taps and the immediately adjacent piping is critical, therefore, to controlling infiltration. You've got, because they are feeding the main trench, or the main trench is feeding the lateral connections with water. As the service pipe trench floods and the main trench water depth increases, that waterhead can drive both sewage and lateral infiltration back into the owner's service pipe and, of course, into his home. And John mentioned that. That's one of the problems. This diagram clearly shows that lateral connection trench is an integral part of the sewer main trench, and this area has to be addressed in any infiltration reduction scheme. I think you can imagine, without static pressure testing during pipe installation and acceptance, how well do you think the service tap connections and those aligning pieces of pipe segment were installed, especially if it was installed after the main had been installed with a hammer tap or some kind of a break-in tap connection. Many of those joints probably were put together, and in from 3 o'clock around to 9 o'clock through the 6 o'clock position, there may be little or no seal, or it certainly has failed. Okay, soon after the storm stops, the water will certainly begin to drain from the system. It drains from the storm, it drains from the sanitary sewer. But the trench system is still fully charged. This trench water, now loaded with bedding fines, soil fines, continues migrating, creating a high rate of infiltration through lateral and main pipe joints and tap connections into the sewer system, and continues until both the storm and sanitary and service pipe trenches, the water level until it has dropped and stabilized basically at the pre-storm level. So now we have a results of what that is happening. You can begin to see here. The water's all drained away. There's some water still in the sanitary system. But over time, you've lost fines and bedding soil around the joints, under pipes, even under structures. It just continues. This has been going on for 50, 60 years. It didn't just start in the last 10 or 20 years when we started to look at it. From the very first rain event, these underground channels, this washing away of the pipe bedding fines has been continuing. And it continues, unstopped. And of course, if you just let it go forever, you'll see what happens. We've talked about it. You've seen the catastrophic failures, but there's a lot of underground semi-failures or approaching catastrophe. Of course, this is worst-case condition. And of course, this is what we all see. This is what we're used to seeing. You pull a manhole cover, and you see the bricks, and you see the water coming in all over the place between the roadway, in around the top of the manhole. You go down a pipe, you'll see it coming in at the joint. It's very obvious. This pipe is fully submerged, okay? Water's coming in at the 12 o'clock position. You can't see it because it's flowing here at the 6 o'clock, but the odds are it's coming right in there. Okay. This is the simplified storm history hydrograph at the treatment plant. I think we've all seen this in very elaborate forms, but this is basically what it breaks down to. The blue is the storm inflow water that gets to the treatment plant. That's very obvious. The pink area is composed of inflow and rain-derived I&I, just discussed. It's hard to quantify separate inflow and infiltration rates that make up the combined RDI and I. But if you take some time and you learn and you understand your utility trench systems, I think you can begin to control trench water infiltration. It may take some creativity, but you can do it, okay? Remember, if you just fix the joints and manholes that appear to be leaking, then the trench water will continue migrating downstream to the next available entry point. To stop infiltration, you have to address all sources of I&I in each collection basin, including, of course, manholes, mains, lateral taps, and the initial 4 to 6 feet of the lateral pipe sections. You have to try and get above the trench water level in typical rain events. That's your target. Okay, I thank you for your time. Any questions?
Very nice presentation, Dick. Yeah, we will have a quick Q&A session here. If you have a specific question, please feel free to type those questions into the box as directed during the early part of this presentation. I do have a couple that did come in, and I think they're from some people that understand grouting in general. One of them was, we have done a lot of main lining, and we still have substantial I&I issues, yet our tap connections and laterals are the property owner's responsibility. Do you think sealing or grouting the liner cutout will help or do some benefit, or do we have to grout further up, and how much further should we grout up the lateral?
You putting that to me, John?
Yeah, absolutely, to you, Dick.
Okay. Yes, I think you have to. I think this presentation makes that very clear. Even if the responsibility of the city stops at the lateral connection, you have to not only do just the connection, not just the annulus between the old pipe and the liner, but you've got to try and get up there 5, 6 joints into the lateral to get that trench isolated from the main, so that the water has to rise substantially up into the lateral trench before it can start to come through lateral connections or lateral joints and flow back in. You got to do it.
Yeah, I would agree. Another quick question from the audience. If you have any experience, do you think clay trench dams would help this phenomenon, Dan? I mean, Dick?
Yes, I think this is often spoken about. There's little evidence where they are because they were buried. The trench dams were intended to do that initially, and they were successful, I guess. Otherwise, they wouldn't have put them in. Another way to look at it is, if you pump enough grout at any particular joint, you are almost creating a trench dam. But that is not what the tradition has been for grouting. You can also probe grout at certain points and build a dam. The thing to keep in mind is that if you dam it up high enough, though, that water is going to go somewhere, and it might actually come through the surface. But it's worth doing.
Very good point. Very good point. Well, I think we'll move on. We've got another quick poll question to ask, and that one's pretty simple. It's just, how long have you been involved in this industry? So if you could please just answer that poll question, and we'll get some results really quickly here. We've got about 60% voted, and it looks like we've got a lot of people that have got a lot of experience. Over 40% of the audience has been in the industry for over 20 years, about 26% in that 10 to 20 year span, 18 in the 6 to 9 years, and the balance have just got started. So I appreciate your help with the poll questions. With that, I think we'll go ahead and get on to our next presenter so we stay on target for time here. Our next presenter is Daniel McGill. Daniel began working at Avani International in 1992 and assumed the role of president of the company in 2008. Headquartered near Houston, Texas, Avani serves the municipal, industrial, and geotechnical markets with acrylamide, acrylic, acrylate, grouts, foams, gels, microfine, and ultrafine cements used for groundwater control. Mr. McGill has a bachelor's degree from the University of Houston and a master's degree from Penn State University. Daniel, you can take it from there.
Cool. Thank you, John. Good afternoon, everybody. We'll take a few minutes to just look at better understanding chemical grouts. Many of you are familiar with them, but we'll take a moment to look at a simple definition. Chemical grouts are liquid resins that turn into impermeable solids in a predictable time frame. Essentially, they're used to stop leaks in above-grade structures, stop infiltration into below-grade structures, stabilize soils, control groundwater, and also seal the annular space between the hose pipe and the liner. And I'll define a couple of places where chemical grouts are used, and what's significant about it is we talk with municipalities all over the country, and they're amazed to realize that the same chemical that they're using to seal mainline joints and laterals is used all over the world in a variety of applications and even in different markets. In the 1950s, acrylamide grout in particular was first used in the U.S. For soil stabilization, and then in the 60s they began using it for municipal applications. Here this slide shows in the 1980s, 1985 in particular, the U.S. Department of Energy started a 20-year program where they tested 7 different types of grouts. And their goal was to determine what they wanted to use to encapsulate radioactive waste, so it had to be a long-term solution. And this image over here shows the project, and this illustration depicts they did it via probes from the surface. But after their testing, they chose acrylamide grout because they determined it had a 362-year half-life in the soil. That became very significant for the grouting industry because we know the grout lasts a long time, and it really comes down to, as the NASCO spec suggests, proper mixing, proper injection. And we'll talk a little bit more about that in the future. Subways and tunnels. Here, this image shows the Toronto Transit Commission, for example, has been part of a 14-year program. They drill a hole through the wall. They pump the grout into the soil side, the positive side. It cures, and then water can't get to the structure anymore, so they don't have to chase the water from crack to crack. They call that curtain grouting. Grouts are used in concrete and earthen dams, mines, and tailings dams. The image on the left, I got to go into a mine 1,500 feet down, and they cored 260 feet and then grouted that core. And then they went 8 feet to the right and 8 feet to the left and cored again. And you could see the grout in those cores, even though it looks like it traveled through solid rock. It was super fine cracks, and it had at least a 16-foot diameter spread there. Slab lifting, primarily foams. These foams you can inject under a concrete slab. It will not only stabilize it, but it will lift it back up. And you can drive a truck across it in 15 minutes. Ed Paradis will talk more about foams coming up. Underwater applications, tunneling and TBM applications, pre-excavation and dewatering. This image depicts a project in Michigan, the city of Dearborn. They were putting in underground storage tanks as a means to deal with their sanitary sewer overflows. And these tanks were massive. They're 120 feet wide and 150 feet deep. And a couple of locations, when they drilled into the ground to start construction, water shot up into the air 20 feet due to artesian pressures underground. So their options were to dewater or to do pre-excavation grouting, and that's what they chose to do. So you can see a double row grout curtain here. And they pumped acrylamide grout, like 200,000 gallons of that, and 10 to 20,000 gallons of ultrafine cement. They created an area where they could begin to excavate and sink the caisson, sink the tank, and not have to deal with as much water infiltration into the construction site. Beneath and around underground structures, you see a manhole here. As you saw in the tunnel, it doesn't matter what the structure is. You can seal it. You can stop the infiltration and the leaks without excavation. And then finally, mainline sewers, laterals, and manholes. And in this image, you'll see what Dick talked about as sealing the entire system. If you seal the mainline joint here, the water follows the path of least resistance and comes in wherever it can. Maybe that's the manhole, maybe it's the lateral connection, or maybe it's several feet up the lateral. So you really need to address the entire system in order to see reduced flows at the treatment plant. There are different types of grouts on the market. You know, there's cement and bentonite, silicates, urethanes. The primary municipal grouts are in the acrylic family or the urethane family. For acrylics, there's acrylamide grout, NMA or acrylic, and acrylate grouts, all similar and all used in the same way. And then the urethane family, you have hydrophilic or hydrophobic gels and expansive foams, and they can cure flexibly or rigidly. And I'll focus more on the acrylic side because they're used more often in the main lines or the laterals. Why is that? If you look at the picture on the top right, you see they're pouring component A and component B together into a cup, and it has the same viscosity as water. So that makes it the thinnest product on the market in terms of grouts. And they go all the way up to the thickness of cold honey. So this is very, very thin. It's just like water. And the bottom photo, you can see it has become a firm gel. And this gel time, they did this in about 25 seconds. That's a standard gel time for maybe grouting an 8-inch pipe. And you can control that gel time in the field anywhere from 3 seconds. You can make it become a solid in 3 seconds, all the way up to 14 hours. So being able to control that in the field is very important and unique to these types of grouts. There's no suspended particles like you would find in cement. You know, if you inject cement into rock or underground, it can only go as far as the particle size will allow it to go before it gets clogged up. These grouts, there are no suspended particles. They just are a liquid that turn into a solid. It says here field adjustable gel strength. If you're in the grout truck and you know you've got a lot of dilution in this line or in these upcoming joints, you can actually pump a stronger grout just by changing the batch in the truck to deal with that dilution. There's soap and water cleanup. These grouts are not activated by moisture, which is a plus. There's no need to carry solvents on the truck. And they have a successful track record. For acrylics and acrylamide in particular, over 60 years now. I'll throw in here again just the NASCO and ICGA came out with a spec last year that's been very helpful, both to contractors and to engineers. But really, proper mixing is key, knowing what you're mixing. And because of that, an inspector can go onto a truck now and actually determine the concentration of the grout being pumped and its resistance to head pressure. So it gives them more of a barometer. It makes it more less of an art and more of a science. This is a quick quote from a white paper from Dr. Vipulanandan. He's the chair of the Civil and Environmental Engineering at the University of Houston and also the director of SIGMAT. And he says, based on its cost effectiveness, durability, and method of leak repair, chemical grouting has proven to be the least expensive remediation alternative for stopping leaks and infiltration. And John, I'll pass it back to you.
Thank you, Daniel. We got a moment here for a couple quick questions. We're getting quite a few coming in from the audience. I appreciate that. And we did have a little echo in that last presentation. For those of you that were commenting to that regard, we'll work on that, see if we can make that change here for the next session that Daniel's involved. I've got a common question that came through, Daniel. It's probably one that you get on a regular basis, and it was, what is the design life of these grouts?
Okay, John, can you hear me? Is that echo gone now?
Yeah, it's much better.
Okay, sorry, I don't know when it started. Just let me know if you have any more difficulties. I got off of a headset and onto a speakerphone. The design life of the grout, as I mentioned, the U.S. Department of Energy says acrylamide is a 362-year half-life in the soil. And that's really important. A lot of people say, well, it shrinks and shrivels up, and that is absolutely true. If you put it on your desk or set it out in the parking lot, it'll shrink and shrivel up. It won't last a single day. But when it's injected properly underground, it'll last a long, long time. That's why they chose it, to encapsulate radioactive waste. And in terms of being in a moist environment, that's what it wants. Even if you're in a slightly humid environment, that's enough to keep the grouts happy. We supply product to Egypt, which is a very arid environment, and there's enough humidity in the soil to keep the grout happy. When it comes to urethanes, we say they'll last the life of the structure. Again, the goal is you've got to get it out into the soil and pump enough grout, and the new spec will help contractors determine what gel time to use and how much grout to pump based on the packer size and the diameter of the pipe.
Very good. And then I get time for one more quick question. Is there any difference between acrylamide, acrylic, acrylate to use them in specific areas? I guess that's a pretty loaded question for you, Daniel. I guess maybe when would you use those specific grouts?
Okay, so the three in the acrylic family, you can use all three of those in the same types of applications. They have similar viscosities. What it comes down to is really the third-party testing on longevity for each of the grouts, and also their taste history, how long they've been around. I want to say acrylamide since the 1950s, and both acrylic and acrylate since the 80s. And then it comes down to cost, effectiveness, the price of the grouts, and also shipping. Some of them you're shipping a liquid and paying for that. Some of you are shipping a bag of a granular material. It's like a salt or a sugar. So you could use them in similar applications.
Sounds good. I appreciate that, Daniel. I think with that, we'll move on to our next presenter to try and stay on track.
Thanks, John.
Keep the questions coming, everyone. We do have one more quick poll question to ask. What is your experience level with chemical grouting? Please choose one. I appreciate everybody's quick response to these poll questions. It seems to be working out very well. Overwhelmingly, we've got over 70% of the people have very limited experience and they're anxious to know more. About 20% have some intermediate experience, and only about 5% of the audience is proficient with the use of grout, which is what most of us in the grouting profession typically run into when we're doing presentations on this subject. So we really appreciate your attendance in this event. With that, I'd like to introduce our next speaker. It'd be Mark Engdahl with Logiball. Mark has been involved with Logiball since 1994 and currently serves as president. Originally involved in sales of test and seal packers and pipe plugs, Mark slowly moved into design and fabrication of test and seal packers and eventually the product line manager. Mark has been involved with the development of ASTM standard practices for application of chemical grouts for infiltration control, has given numerous presentations on the subject. He is active in NASCO as a committee chair, board member, and past president, and is a founding member of the ICGA, the Infiltration Control Grouting Association. He was a co-recipient of the NASTT Most Innovative Product Award and the WEF Collection System Most Innovative Product Award. Mark has actively participated in the Aries Grout Boot Camp, training over 200 attendees in the last 8 years. With that, I'd like to turn it over to you, Mark.
Thank you. I will be discussing grouting equipment, but typically from operating in smaller pipes where man entry is not possible in these cases, and I'll let Ed talk about manhole grouting later. So here's your pictures, typically your grout truck manhole setup. Typically we're working with a two-man crew. We have the operator inside the studio here, basically doing all the television work and the reporting, and his back man is basically controlling everything in the back end of it, whether it be hoses and making sure that we have grout that's ready to be pumped when necessary. Since we're working in smaller pipes, we have to use test and seal packers. What you see here on the left is the end of a packer, which is a flow-through element here, which is housing inside right here is a transducer, which is basically basically an electronic gauge to basically report what we're seeing in the void between the packer and the pipe back into the studio in the mobile unit. So data will be displayed on the mobile unit and in the screen telling us what is going on once this packer is inflated, either testing or sealing pressures. The mainline packers, basically the grout does not mix until it comes out of the packer, as you see in the picture on the left. It will spray out, fill up with that void basically between the inflated bladders and go out into the soil. Typically they have two hoses for the chemicals, one to be inflated and a separate airline here to perform an air test. These packers are available from 6-inch mains up to 144-inch main lines. We were talking earlier about lateral tap connections and laterals. There are lateral packers out there, anywhere from 6-inch to 30-inch main lines that will allow the operators of contractor municipality to seal a predetermined distance up in the lateral from the main line axis only. Typically, these will run off a 5-hose system, 2 chemicals, 2 airs, and another air for the air test. Configuration of these units can be interchanged basically to seal the first couple of feet or as far up as 30 feet in this picture. There are flexible push-pull packers that are available if you have above ground access for the laterals, where you could basically pull these into position. They will allow you to seal the joints in the laterals but not the connections. Or if you have laterals coming into manholes, they would be used to push in place from the manhole axis up towards the homeowner. The pictures at the bottom, picture on the left at the bottom basically shows infiltration coming in from a lateral. The next picture shows the end of this push packer, which has been used to seal the 90-degree bend in the lateral from an above-ground access. Preparing for insertion of camera packer, top and bottom hole, grout, hose, and TV cable rollers. As you can notice, the operators in this picture are setting this very neatly, so this unit can be winched down into the main line. Everything is taped nice and smooth and make it for a better operation and more production in the day's work. Test and seal packer capabilities. Over the years, there's been different packers built, put in the field, box culverts, as you see on the left, long span packers, and this you have to be careful. A longitudinal crack will be defined as a structural defect, so this can be used prior to another technology to rehab or renew the pipe. We're seeing more and more storm sewers, elliptical pipes being installed. The joints need to be air tested and sealed, so there's different units out there that are available. What we're seeing here is the back of the CCTV mobile unit. We have in this case, the penta hose, which is used to deliver the chemicals from the unit through the hoses, the air lines for inflation, vacuum, and air testing. What you can see here is basically the TV reel and cable being used for the pan and tilt cameras, zoom these days, very nice to have. This truck happens to be also a cutter truck, so you can see the reel over here and the generator on the back end of, not generator, air compressor, excuse me. Also in the back of the mobile unit, what we're seeing here are stainless steel tanks with heater bands around them. So during the winter time, at least up in the northern part, it's nice to keep the water at a similar temperature to the sewer water. Secure lids, they have electrical mixers, so basically you can mix your A and B components first, making sure everything is done right. 3/4-inch lines bring in the water in, because these are basically water-based solutions. And bottom drip pans over here, so if anything falls in, then everything's safe. So there is some equipment involved here, but it's being done daily by these contractors and municipalities around the nation. Unfortunately, the manholes are not always located in the middle of the streets, so this equipment does allow for some ease of access to these points. Every job site may be different. Contractors usually adapt, and they've found ways over the years to do so. On Operator's workstation. You'll notice from the picture on the left that there are two screens. One is basically directly with the TV, and the other one's used to generate reports with the computer system. The operator basically sees what here, punches in, and it's into the software with, in this case, the PACP grouting codes. The information on the panel over here is basically the control station. Gives you information about the testing grouting pressures, the amount of grout that's been pumped, and basically all the controls to make it a successful operation during the test and seal procedures. Questions?
Very nice, Mark. Yeah, questions are really coming in hot and heavy, so I appreciate that from the audience. A couple quick ones for Mark. More on the equipment size. What size access would be required for a 30-inch mainline packer if you were trying to install that into doing some lateral grouting? So if you were trying to install a 30-inch, I guess you're looking for a lateral grouting packer, which I don't know if that you made before, Mark, but what size opening would you need to have to get that into place?
If I'm not mistaken, we're roughly 26.5 inches OD. I'm going on memory here, but plus or minus an inch. So in many cases, the manhole ring must be removed, and once down in the pipe, I would try and drag it as long as you could before you took it out again through another access.
Okay. So, and then any idea what the typical cost of a grouting truck might run?
Depending on all the bells and whistles, I estimate with the truck probably somewhere, I would say $280 to $320, depending on what you're going to put on the truck and what kind of box, the equipment, pumps, tanks, bigger. That's typically what I'm seeing, even though I'm not in selling grout trucks, but that's what I've seen recently.
Sure. And then one last question, more related to the test and seal procedures used for grouting. Would you suggest air testing all joints prior to grouting consecutive joints?
If you are setting up to seal only the visually leaking joints, you may be in there for a while, especially if you start on the downstream and you work your way back up. I would definitely recommend testing all the joints. That's basically your pass, no pass test. And even if you don't see any visual information about leaks, it may eventually end up there. So the testing and the sealing is part of the procedure.
Yeah, I would concur with that. We've had projects where we tested only the leakers, only to come back a year later and find a bunch of the other joints now leaking, not the ones that we sealed. So
I concur to that.
Okay. All right, well, we'll move on. Thank you very much, Mark.
Thank you.
And at this point, we've got another poll question to put out to the marketplace. What is your experience level with chemical grouting was the last one. This one is, how much time have you spent working on a CCTV/grout truck? I suspect we'll have only a few people in that category, as it looks like many of us in the audience are consulting engineers. We've got about almost 70% have voted, and the majority of people haven't spent a lot of time in a CCTV/grout truck. Well, you need to take some time to get out there and spend some time on these vehicles. It's quite an exciting operation. So I thank everyone for answering that poll question. We'll move on. The next presenter, we've got a kind of a series of presenters coming up now. We're going to run 3 concurrently before the next Q&A session. We'll be starting off with Ed Perdis from Denif. And let me get you his bio. Ed is with Denif, which is now owned by W.R. Grace. He's been there since working on 20 years, I guess, a little less than that. That is responsible for the southeastern United States and the Caribbean islands and heads up their municipal markets. He attended Boston College and served with the United States Army. He is active in various organizations, including NASCO, NASTT, and DFI, which is the Deep Foundation Institute. He has 20-plus years in the chemical grouting industry as both a contractor and working for a manufacturer. Like I said, Ed's going to start off and kind of cover manholes. Then we're going to have Daniel McGill come back in and handle main lines, and then Mark Enkel will finish up with laterals with specific techniques for how to handle those specific types or specific locations in your infrastructure. With that, it's all yours, Ed.
Good afternoon, everyone. Thank you for joining. I'm going to cover grouting of manholes and get into the final end of it with some point grouting, which is a probe type method where you're non-excavating, non-disruption to the community. Controlling infiltration in the storm or sanitary sewers is always a major part of reducing unwanted groundwater. Without stopping these leaks, as you've seen in some of the other presentations, you're going to have catastrophic failures such as this project up in Chicago. This was back in 2004, and I think the only person that was happy here was the precast manhole manufacturer. Chemical grouts have been used for sealing leaks for well over 50 years. When the correct material is chosen and the correct procedures are followed, this technology has proven to be a long-lasting, standalone repair. Some of the applications where you see chemical grouts are here in the manhole grouting, lateral grouting, storm pipes, and then the probe grouting that we'll get into up front. This is basically your collection system. Geotechnical market is basically the same, which is done, as Daniel discussed earlier, via probe grouting or fracture grouting into tunnels. The four basic categories, again, that Daniel had talked about earlier is the acrylic, and acrylamides, and then the polyurethane. The important thing about when specifying the correct material is the wet-dry cycles, freeze-thaw cycles, voids, movement, size of cracks, volume of leaks, and the type of structure. Those are very, very important to remember when you're specifying the products. We've had engineering firms over the years say we've tried chemical grout, it didn't work. Then you ask what material they tried. It may have not met one of the wet-dry cycling or freeze-thaw cycles. There's NSF 61 approved products for safer environment concerns, phthalate-free materials out there that will help you specify if there's concerns to the environment. Two types of polyurethane grouts are hydrophilic and hydrophobic. The hydrophilic materials are a resin only. There is no catalyst. They do have a great bond, but because they absorb so much water, they do have a medium to high shrinkage rate. The hydrophobics are rigid and flexible. They're resin and a catalyst, a good bond. They have an adjustable set time, such as the acrylics and the acrylamides, because they have a catalyst that goes with them. With the hydrophilics in a cold climate, you're at kind of the mercy of the water temperature for your set, so you may have a larger waste factor on a higher volume leak. The repair process for sealing both brick and precast structures is commonly performed through the procedures. Though the procedures may vary, the end result is the same: a dry manhole that will prolong the life of the collection system. A lot of municipalities and specifications out there have gone into where they're going to grout and coat everything after they're done. And if the manholes are not eaten up with chemical attack, you can get away from using that coating, prolong the life by stopping the leak, and then your budget will stretch a little bit further. Step one when grouting a manhole is to slow down the leak. Slow down the leak using oakum, hydraulic cement, mixture of both. Don't just go into a manhole and start pumping material and letting it wash down the main line. Get in there, soak the oakum in the chemical grout, hydraulic cement, slow the leak down to minimize your waste factor. Entering the structure is done with equipment like this, except one problem here is that I wouldn't enter a sewer manhole with a cigarette dangling out of my mouth. Pre-mixing the oakum and the resin, soaking the oakum in the bucket with the resin allows the resin to absorb into the oakum, so when you stuff it in and around the pipe penetration, the active infiltration coming in is going to react the oakum-soaked material, stuff the leak off. Then you can back grout it with some cartridge materials if you're using a cartridge application. Injecting methods may vary from contractor to contractor, but the goal is the same. Stop the water. Brick manholes, you want to drill to the outside of the manhole through a brick, not through the mortar joint. So your injection port or wall spear will have a solid area to lock onto. Start the injection at the bottom, working upward. Brick should be curtain grouted to ensure that the whole area behind them is sealed. Precast manholes, repair all pipe penetrations prior to grouting. Open the rings if they're too wide. Drill the injection holes into the ring in a clock position, and then start the injection again from the bottom ring, working upwards, shooting the rings. Address all cracks that may be visible on the sidewalls. Here's a brick manhole that was injected with chemical grout, and you can see down there at the very bottom where the grout had gone through the brick to the outside and has come back in. Injecting a pre-coated manhole, you see the moisture and water down here on the ground. After the grouting, you see how the grouting will come back up. This is a precast ring. You see over here there's a port in there. Actually injected the entire ring of the manhole off of 2 ports. Again, another ring sealed. And down in the bench, you see down at the bottom, they actually used a plug to minimize the grout that was traveling down the main line. So that isn't a sealed up main line. That was actually plugged off. But you see in the ring how the grout had traveled and sealed. Here's a high flow leak. Picture on the left was the infiltration. Picture on the right was the grouted leak. Point grouting is a procedure used in stopping leaks in below-grade pipes. This procedure is cost-effective and requires no excavation with little disruption to the community. Basically what you're doing here is you're setting your probes through small holes in the street, sidewalks, or whatnot. Your probes will go down to a distance of 1 foot below the bottom of the pipe, as you see in this drawing here. Water blasting the probes into the ground can be done by the vac truck. You can drive them down if the soils permit. Probes are inserted to a depth, again, of 1 foot to the bottom of the pipe. Polyurethanes are typically shot here, so keep in mind that polyurethanes are a foam. They're going to expand upward. So if you stop at the top of the pipe to do your grouting, your grout's going to expand above the pipe. So get down below the pipe, let the chemical grout work to your advantage and expand up and seal the leaks as you pull the probe up. Injection can be estimated at 1 gallon per vertical foot on an average, stopping at the top of the pipe. So you have a one gallon from a foot below, 1 gallon at the bottom of the pipe. On the 24-inch pipe, you'll have another gallon, so basically a probe's going to be 4 gallons to seal a 24-inch pipe. Recap, check the structure after injection to ensure that all leaks have been sealed. Document the job file, material used, amount pumped, amount of infiltration stopped. And is further coating or lining needed for that structure. The amount of infiltration can be anywhere from minor leaks to we've had success up to 2,000 gallons a minute. The chemical grouts can be used in that range of infiltration. Thank you.
Very nice, Ed. Appreciate it very much. With that, we'll move on to mainline and how we tackle mainline leaks, and that will be Daniel McGill with Avani International.
Cool. Thanks, John. Hope you can hear me now. So if I focus just on main lines, there are several different types of technologies out there that are used in main lines. Some of them are listed here. I think there's about 8 different types of lining, but it includes dig and replace, lining, pipe bursting, and chemical grouting. And if you notice, all of the technologies in black have one thing in common, and that's that they are structural repairs. And so if you have a structural problem in the pipe, then you need a structural solution, and that's great. But if you don't have a structural problem, then you'll save a lot of money to use chemical grouts to stop the infiltration. Sometimes putting in a liner is kind of a catch-all answer, and it doesn't necessarily stop all of the infiltration, and it's also not necessarily needed. In this image, for example, this is a mainline pipe. I think it's a 42 to 48 inch pipe. It's brand new, and when they put the pipes together, they roll the gasket. So there's a lot of infiltration here. Obviously, there's no need for a point liner or a section liner. Visual Sewer was able to go in and grout this and stop the leak. But that's just a quick example of, if you've got a structurally sound pipe, you can seal it easily with grouts. This next slide, the process of sewer failure, is probably my favorite slide in this presentation. It's also consistent with the way PACP teaches the process. In stage one, you see that the pipe is leaking. It's the main line is straight as a rifle, and you've got infiltration coming in. If you grout it now, it'll last decades. In stage two, you see that there has been no preventative maintenance, so now you're starting to see undulation of the main line, and you're starting to lose your system. Even though the sections, maybe it's, as Dick said, it's clay pipe, the pipe is still fine, but you're losing those joints. You could grout it as well now as part of a preventative maintenance program. And then stage three is failure of that pipe, and now you can't grout it, and you've got to do something much more costly. Here, we'll try to take a look at a quick animation. Hopefully this will play well on your screens. This is a 30-second excerpt. You see the camera on the right, the packer on the left. Even if that joint wasn't visibly leaking, as Mark said, they would do an air test on that joint. Here it's visibly leaking, so it's they know they need to grout it. They pump once, let it cure, pump again. They try to pump till refusal per the spec. And when they remove the packer, the majority of that grout will just break off and flow to the treatment plant. And what you're left with, as shown here, is what they call the grout donut outside the pipe. So there's a myth that grout only seals the joint itself, but in reality, the contractor needs to pump enough material to get into the soil. It's a soil sealing process, and that will prevent exfiltration of sewage. It will also prevent infiltration of groundwater. And here you see what they call that the gel soil matrix outside the pipe. This is an image of the grout donut 25 years after that line was injected. So in terms of working with structural technologies, chemical grouts really help or complement structural technology. This is from the EPA, from a document they published last year. CIPP is excellent long-term repair, but will not provide permanently watertight system. And here from the Army Corps of Engineers, the liner should be adequately sealed at the laterals. So let's say you've got a lining scenario. You need a structural solution. Sometimes chemical grouts can be used before lining. Let's say your joint looks like this. You've got a gusher per the PACP terms. If you don't stop that water before coming in, you could get a bubble or a lift in the liner. At the very least, you'll get a weakening of the liner. So they'll grout that and then line that section of pipe. In the other instance, for lateral reinstatement, hopefully this plays well, what you're seeing is infiltration, water coming in from the top and the side. That's between the hose pipe and a liner. It's clearly not coming from the lateral or from the house. So that's coming in the annulus, and they'll grout those lateral connections as well. So you want to stop the water so that you don't end up with either of these. The photo on the left shows leaks and deformation of a liner and a main line. This is, I believe, a 36-inch line in Granite City, Illinois. And they had lined it 20 years ago. The water that was coming into the hose pipe and traveling in the annulus brought soil and fines with it, the pipe bedding with it. So it developed voids outside the pipe, and the pipe shifted, which caused a shear of the liner at the joint. And so all of that material came into the pipe. And then the image on the right is a manhole. They didn't stop the water before they put this coating on, and so you had failure of the liner or coating. This is just a quick case study to sum up main lines. water and soil is entering the system 24/7. This is a 1992 case study in Sunrise, Florida. They had flows equal to 700,000 gallons per day at the pump station. And the city sealed a 500-foot section of 12-inch pipe. The joints were every 5 feet, and they pumped 700 gallons of grout at a cost of about $6 per gallon. That's just the cost of the grout, mixed grout. They reduced the flow by over 600,000 gallons a day, and they were spending $1,300 a day to treat that infiltration at about $2 per 1,000 gallons. So if you look at the payback timetable, you take the cost of the grout, $4 grand divided by what they were spending per day to treat that infiltration, and they made their money back in 3 days. Again, that's only including the cost of the grout. I know there are a lot of other variables to take into consideration, but at the end of the year, they had a total annual savings of $480,000. This rule of thumb here at the bottom just shows, according to the NASCO spec, it's the contractor is going to try to pump 1/4 of a gallon to a 1/2 gallon per inch diameter of pipe. So easy math, if you're in an 8-inch pipe, you might try to pump 4 gallons. And you may pump more than that if you've got a larger void, and you may pump less than that if you've got a tight void space. And Mark, I'll transfer over to you. Thank you.
Thank you, Daniel. All right, now we've learned a little bit about mainline sealing. We're going to move into the lateral part of it. Laterals are usually the last part of the equation where we're going to be attempting to seal off infiltration. We've accessed the manholes and the main lines, repaired these sections in the basins. Now water moves, and guess where it comes from? At the service connections and the first few feet in the service line. Water doesn't disappear, okay? As we fix these issues in the mains and the manholes, groundwater table rises. The next point of entry is the laterals. You go back 15 years ago, infiltration numbers of lateral connections was very low. But as more work is being done around the country, people are finding out that water is coming more and more from the service connections. Now, the grouts commonly used in controlling infiltration in laterals. We have our acrylamides, our acrylates, acrylic resins, urethane gels, and urethane foams. Not recommended for service connections, urethane foams. Our typical setup is we'd have the truck on this end with all the controls, the pumps, tanks, etc., the TV system. At the opposite end over here, we've got a remote winch. And if you look at the top picture right here, this is typically what's going to go down into the sewer. You have your pan and tilt camera that's on a set of skids, a certain distance from the lateral packer. Over on this end is the lateral packer, and everything here will be towed down the mainline sewer. Okay? Lateral tap connection grouting prep procedures. What's the first thing you have to do? Of course, you have to clean the mainline sewer. Videotape CCTV inspections of the mainline and pan and tilt of the lateral. If the intent here is to seal effective sealing distance that are past 6, 7, 8, 9, 10 feet, whatever it may be, strongly recommended to inspect the laterals, either from the main or from an above-ground access. Depending on the TV results, cleaning may be necessary before anything is done to the laterals. Okay? Identification of the diameter of the laterals. Are they 4-inch, 5-inch, 6-inch? Protruding taps of more than 5/8 or anything that's basically going to prevent the equipment from going down the pipe, sealing either the bladders, the main line, or lateral, must be removed in order to provide a good seal of the rubber elements. Bypass pumping is normally not an issue, as the packers are only inflated for a short period of time, which basically cost savings in the long run. The lateral packers work best with the 5-hose system, as I said earlier. You have your chemical hoses on the extremities, mainline inflate, the air test, basically to pump air into the void, and the controls or the hose for the lateral bladder for inversion and vacuum. As you saw earlier, the same mainline units can have different configurations. One important thing is if you decide to go with a 15-foot bladder, well, from here to the end it will be 15 feet, so you are dragging a longer piece in the main line. So typically, just an above-ground picture access demo here, the packer would be winched into position. There's a motor for the rotation clockwise, counterclockwise to line up the bladder. Once the operator lines up the bladder, air is used to invert the lateral bladder out on its full length, where the last 12 inches of the bladder will seal up against the pipe. The remaining portion will expand slightly less, allowing the grout to be pumped from the main line part, fill up all the voids, travel along the yellow bladder, and out through any existing defects out into the soil. Once the test and seal procedure is performed, the bladder is brought back with a vacuum into the mainline packer, which is then moved to the next connection where the process is repeated. One of the things that we are looking for from a manufacturer is the void between the packer and the pipe. Manufacturers will provide you with packer-to-pipe voids, which is important to determine an appropriate gel time according to your pumping rate. Here we go with the gel times of the grout. Every time we mix a new batch of grout in the truck, a cup test is performed to at least determine the gel time of the grout. Why is that important? Well, we do want the grouts to exit the defects before they gel. Okay? So if you know the packer-to-pipe void, you know the pumping rate of the equipment on the truck, or how fast are you pumping A and B side combined, then we know that we need so many seconds to fill that void and determine how long our gel time needs to be, depending on how far we want the grout to travel outside the pipe. Infiltration and lateral reinstatements after mainline relining. Contractors are putting great pieces of pipe in the ground, but unfortunately we have to service the communities and the homeowners, so they basically put holes in them. And water finds its way into the main line back through these openings. Here's a quick animation of lining in conjunction with grouting, where technologies basically complement themselves. Line pipe, reinstated. Groundwater, of course, does not disappear, just moves on to the next point of entry. Packer is basically pulled into position, rotated. Air pressure basically to invert the lateral bladder out into the service. And in this case, effective sealing distance may be 10, 15 feet. So we assume that we expect the line to be pre-TV'd and possibly cleaned. Grout is injected in stages in this case, where it basically travels along the pipe out through the existing clay or concrete pipe defects into the soil. Bladder is removed after the post-test operation, and basically moving on to the next service. So the soil has been sealed around that structure. When it comes to cleaning laterals and you don't have a clean-out access or you can't find one, there are tools out there to prepare the work to be done. The picture on the left shows a root intrusion at 32 feet from the main. A device is basically a cleaning nozzle and hose basically launched into the lateral to clean that distance from the mainline connection. So pre and post can basically tell you what this thing can do. Going back to the sealed service, grout will travel between the liner and the hose pipe. If the gel time is long enough and conditions are appropriate, we will find a way out into the soil. So it's basically a double seal between the liner and the pipe and out through the existing defects into the soil. And of course, up the lateral on that predetermined distance. Crucial information provided by the equipment. This is basically a shot from a screen in the truck. The operators, inspectors in the truck, what they see basically here is an inflated packer against a piece of pipe. We need to have some kind of information come back, whether it be testing or sealing pressures. On mainline packers, you can use gauges or other transducer, for example, to give you a pressure reading in the control room. What we're seeing here is 6.5 psi. We're holding stable at 6.5. We've been holding this pressure for 36 seconds in this case, and a totalizer at the bottom basically tells us the amount of grout that's been pumped either on that joint or lateral. In this case, the 32.5 gallons was used when sealing laterals 30 feet up. The important thing to understand is we need to go out into the soil and saturate the bedding or fill voids. Pictures you see here are from above ground demonstrations where you'd have an 8-inch main line. This is PVC, and basically a 6-inch piece of pipe just stubbed in like a hammer tap, and whatever Home Depot sells for backfill was used here. So sealing the soil in between the soil particles, making this one solid grout soil mass, is the intent, and preventing that groundwater from coming in. And it does provide some kind of support for the pipe here, trying to prevent any fines from entering, or at least stabilizing it around that area. Unfortunately, we see the inside of the pipe. The left picture basically shows us a view with a camera. Here's our lateral at the at this position. The green is basically dye that's being used in the grout to confirm that we have set over the joint and proper mixing. The picture on the right is basically a picture showing us from the main line up into the lateral the residual grout that remains on the inside of the pipe, which is very fine, as you see here. We're talking quarter inch or less. So this grout will eventually peel off because it's not sandwiched in between anything, or it's not with the soil, and go down back into the mainline pipe. Seen earlier, different configurations, same main line diameters. Could be first 4, 6 situations. In many cases, when continuous pumping cannot provide a seal, we're going to pump in stages. What that means is basically we're pumping, we're going to pump through the initial gel band out and build layers of grout until we can achieve a seal, or basically refusal, or it's determined that this one can't be sealed. Sometimes you can find some, I'll call them caverns on the outside, or huge voids, and it has to be determined at a point, can we seal this or not, depending on the void volume behind the pipes. Pushbackers, here's a operator that will use this where he has laterals coming into a manhole. So he will seal this is 5 feet at a time in this case. They're also used to seal service laterals, but not the connections when they have above ground access and it's feasible to push it down through not 4 45-degree bends or 6 90-degree bends, depending on the configuration of the laterals. Here's an example of what's been used. This is a lateral, 90-degree bend, brand new PVC pipe, had a crack in it, water's coming in. Packer was used to seal off infiltration through basically grouted that 90-degree bend. Saw one of these pictures earlier. I want to show you, this is the infiltration before the 90-degree lateral was sealed. This is a view from the main line. This is a view afterwards. And this is a view of what's left in the pipe there. You can see the tip of that bladder right here. So it's basically a test and seal operation, either at the lateral or in mains, where you have your manholes and you've got laterals coming in. Same concept here, where you can use a long sausage where the last or the third feeds it in, half inflated, place the bladder, basically isolate 30 feet of the lateral. Well, successful grouting projects require a couple of things, and one of the important ones, of course, experienced crew and knowledgeable inspector. The grout mix and additives. What are you pumping? The gel time versus a packer pipe void versus your pumping rates. You want to make sure that you can fill the packer to pipe void before any reaction occurs. You want to get that material through the cracks out into the soil. Your void pressure is measured at the packer and pumping through refusal. When the joint can't take anymore and you've pumped to high pressures, higher than the groundwater, and some, then we know we've achieved a seal. Have a logbook of the work performed. It's important for the utility, for the contractor and the engineer, what's been done, how's it been done, and keep a logbook of it. And of course, good specifications. Okay. There are specifications that are out in the marketplace. There are ASTM standard practices for sewer manholes using chemical grout for mainline joints and for lateral connections. And as early as of last year in 2012, NASCO and ICGA standards were released in April. This is one document that you can find on the NASCO or sewer grouting website. With this, I will answer questions and pass it on to John.
Thank you, Mark. I do have a few questions. I'm going to kind of direct these to individuals here amongst the last three speakers. So Ed and Daniel and Mark, be ready for a couple questions coming your way. This one I'm going to send to you, Mark, first of all. The question is, you mentioned that grout has a half-life of 300 years. I think that was Daniel that actually mentioned that. But we have been told from contractors that when there is excess left in the laterals that it will break away and wash away. But we've also been told that the grout injected outside of the sewer pipe will stay for a very long time, which is correct.
There will be residual, if I may answer that.
Sure.
There will be residual grout in the lateral as we are sealing an effective sealing distance. Depending on if there are additives like reinforcing agents added to the grout, they may stay longer into the inside of the lateral. As water runs down these laterals, it would eventually peel that away because it is not sandwiched in between two pieces of pipe, or it is not held together with the soil matrix behind the pipe. So what's left in there will eventually fall in, as long as it's residual grout, the right bladder being used with the right diameters. On the opposite side, if a smaller bladder is used in a larger diameter lateral, the grout ring remaining in there will take a lot longer to remove by itself.
So essentially you're saying that both are correct, that the grout will wash out inside the lateral, but also that you do get a very long. The residual grout will be washed out by the normal operation of the homeowner sewage. Sure. And I think that it's the critical point in that whole conversation is that it's the soil grout matrix that forms the seal on the outside of the pipe, and that's what will give you the longevity of the grout. So
if it's not sandwiched, you're absolutely right.
Correct. Okay. Going back to you, Ed, if you're there. I had a question about FRP manholes.
Yes, I'm here.
In FRP manholes, or thin polymer manholes, there is a concern with grouting pressure. And how do you address issues with pressure in this type of application?
Repeat the question. I had some background noise, please.
No problem. It's in FRP, or thin polymer manholes. Is there a concern with grouting pressure? And how would you address issues with pressure in this type of application where you're using chemical grout?
I always try to do the injection with the minimal amount of pressure possible. It takes, if you're using an injection packer for manholes, you'll end up a minimum pressure of 250 degrees. 250 psi.
Okay, that sounds better.
To open up a grease fittings, which is a common ZERP fitting you find on any of your cars or wheelbarrows or anything of that nature. So minimum pressure of 250 psi should be addressed to start the injection and dial it up accordingly.
So the key is to just use the minimal pressure necessary to seal the leak.
Correct.
Okay. And then, Daniel, I've got a question for you as well.
Okay.
And this one's kind of a broad question. It says, our experience with grouting laterals is that the I&I will reoccur after 5 years, as evidenced by flow monitoring. We suspect that the ground movement is cracking the grout, allowing I&I to resume. Are we using the wrong type of grout, or is the installation faulty, or any other suggestions or thoughts?
It's an interesting question. I don't know exactly what's happening out there. Typically, if you have an acrylic gel, the acrylamide gel is very firm, and if it cracks, it can come back together and still hold water out, kind of a bit self-healing. Why it's starting to leak again, I don't know. In a couple of instances, they might have sealed only the lateral connection or only a few feet up the lateral, and they haven't seen reduction of flow because the groundwater level outside the pipe has risen above 2 feet up, and it's coming into the lateral at 5 and 6 feet up, for example.
Very good point.
Yeah, happening there, I don't know, but those are some things to consider, and also how much grout was pumped. Hopefully, as Mark said, they kept a logbook, how much grout was pumped per lateral connection, because if you're not getting it into the soil outside the pipe, then you're not grouting efficiently.
Yeah, I think that in that instance it'd be recommended to go back and retest those laterals and see if it's actually the connection or if it is further up the pipe that's actually where it's leaking currently.
Great idea.
Good points. Okay, well, let's keep on schedule. We're going to go ahead and hit another poll question here, and then we'll have one brief presentation on specifications and then another final Q&A session. I appreciate everyone's interesting questions. Please keep them coming. The poll question is, what factors do you believe are driving the resurgence of chemical grouting? And for those of you who aren't aware of it, there is a large resurgence of chemical grouting in the industry here in the last 10 years. We've got about half the people voted, and so far it looks like cost effectiveness compared to other techniques is the winner in that poll question, as well as advancements in the grouting techniques, and I concur fully with those two items. There's definitely some cost effectiveness compared to other techniques, lining and things like that, as well as the advancements in the grouting techniques that are being used, especially with the type of packers that we're currently using compared to the ones we were using 20 years ago. So I appreciate everybody participating in that poll question. With that, I think we're going to go ahead and get started on the next presenter, who is behind getting his presentation in place. And that will be myself. We're going to kind of briefly go over how to write an infiltration control specification to obtain the desired results. It's a more complicated question than we can answer in this brief 10-minute presentation. But Mark indicated ahead a few minutes ago regarding the infiltration control specifications. And I'm checking. Are you seeing my slides out there in the audience? I guess I need to double check that. I'm not seeing.
Not yet, John.
Okay. I'll hold on for a second while technology catches up with it. Mark had mentioned at the end of his presentation a specification that was put together by NASCO and the ICGA last year. And it was a pretty dynamic specification. It was put together by a group of peers in the industry, and it was probably one of the most challenging specifications that was written in recent times, at least as far as I was concerned. I haven't participated in that in the peer review process, only because there hadn't been a complete standard specification written in the history of grouting, at least not a comprehensive one to this level. We had a large number of people that participated across the industry. It turned out to be an exceptional document, and I'm patting the back of all the people that participated in the peer review and the drafting of that specification. But it's a document that can easily be used now by any designer here in the marketplace, and can be used pretty regularly without any concern for a bias one way or the other, or issues that might be related to you forgot to include a real important item in that specification. So we're going to kind of breeze through just a few of those items here, and we're still struggling a little technology-wise. Can't tell if it's on my end or not.
Do you want me to pass you the controls again?
That would be great, please. Sounds great. Thank you, Rebecca.
Sure.
With that, we've got the table of the contents of this document is pretty elaborate. It kind of walks through some of the same topics that we've already covered, everything from the products, testing equipment, and then right on to execution. Qualifications and finding good quality contractors in the grouting industry is probably one of the challenges in some marketplaces across the United States. There's quite a few in certain areas, and there's fewer in others. But since the grouting technology is required to use an operator in a truck, and not everything is always visible from that truck, the grouts are pumped into the ground. It requires a technician that is highly skilled. So identifying company and operator experience requirements should be something that you'd always look for when you're putting together grouting specification. The equipment is also critical. It's got to be capable of inducing air under pressure into the void area. When we talk about void area, we're specifically talking about that area between where the packer seals and where the joint is located. We need to be able to pump air into that area so we can actually test to see if the joint has failed and if we have an area where we need to be pumping grout. And the ability to continually measure and record the pressure in that void area is also critical. You want to have the proper equipment in the pipe so you can be able to monitor that pressure during the process. And the pump should be capable of delivering a mixed volume grout at 3 gallons a minute, somewhere in that range, so that you can pump sufficient grout to form the grout curtain or the grout seal on the outside of the pipe. The chemical grouts, they do provide a permanent repair, which is the goal, so stick with proven products. There are some great manufacturers, and we just happen to have 2 of the most outstanding grout manufacturers in the country presented, as part of this presentation with Denif and Avanti as presenters here. Gel times, pressures, and mixing ratios are the most misunderstood items to which an experienced operator can provide significant benefit. When in doubt, I recommend you seek a professional. The equipment and grout tests, a couple things that are typically neglected in most operations with grouting operation, with most operations done in the field, is the initial tests that need to be done to make sure that the equipment's running properly. So at the very start of the project, you need to be doing a pump test to make sure you've got dual hoses that are pumping 2 components of this grout. You need to make sure that they're pumping at the proper ratios. So typically we'll do a quick pump test before we start the existing project. The next, we need to do a barrel test, which is simply taking your packer and putting it on a good sound piece of pipe and seeing that your gauges and your air pressure monitoring devices are all working properly. And finally, throughout the day, you need to be doing grout testing, which is testing your grout to see what your gel times are and making sure that your gel times are what you anticipate. And that'll happen. Your grout gel times will change over the course of a day based on the temperature and other factors that might be occurring in the pipe. Gel times are probably one of the most common questions that we'll get in the industry, and how to calculate that. And as part of this specification, we came up with a standard equation for calculating the proper gel times when you're dealing with test and seal grouting, and that's shown here. Essentially, an 8-inch pipe with a packer void space of 0.3 gallons and a 3 gallon per minute pumping rate would provide for a 26-second gel time. And that gel time is critical to making sure that you get sufficient grout pumped to the outside of the joint to form the proper gasket to provide a long-term seal. Pipe preparation is another item that's kind of critical, and one of the questions that came through earlier was how do you prepare a pipe in large diameters, 18 to 24-inch pipe, especially, specifically, how to handle deposits in those areas. And there is equipment available for handling deposits in up to 24-inch pipe. Chain flailing type systems and water pressure systems are available for those dimensions. So you can certainly find those readily through your normal equipment suppliers, your Vactor and Vacon and such. Those equipment suppliers are typically supplying the type of equipment to remove deposits in those sizes. But you do need to get the deposits and the roots and debris out of the system, and they must be out before you start your test and seal project. So protruding taps also need to be removed. These are time-demanding items which typically should require individual pay items. So in your specifications, you want to include pay items for debris removal, root removal, deposit removal, and protruding tap removal. And lateral cleaning, advanced connection sealing is a completely different process than mainline cleaning. Sometimes we'll see specifications that mix those two together, but they are completely different equipment and require a different approach. So that should be a separate line item in your specification as well. Until probably 5 to 7 years ago, it was more difficult to clean laterals from the main line, but the advance of some new equipment in the marketplace, it makes it a fairly easy process. You can clean anywhere from 5 feet to 20 feet up from the main very easily using the new lateral launching systems. Joint seal verification. All phases of the grout process should be documented, and that's not something that we've seen in the past. Most of the time, the deliverable for a grouting project is simply a video and a report saying that each joint was sealed. But we, as part of this document that we put together, we recommend that there should be proper documentation dealing with a higher level of information. So you should get documentation on the grouting, when it was mixed, how it was mixed, daily mixing logs, cup tests, which is nothing more than just a test on a regular basis as what your gel times are, but those should be recorded. Videos of the joint sealing process. Each joint sealed should be captured on video, as well as detailed sealing reports noting the pressures and gallons pumped into each joint. Lateral connections. After grouting lateral connections, there is a thin residual grout film that may be present on the inside of the lateral wall. As you can see in these two pictures here, that will dissipate and will wash off over time. It's nothing that's going to cause any blockages. It is typical to see that. There's some communities that are requesting that be removed. It can be removed, but it's going to cost a significant amount of extra money to do that removal, and it's typically not necessary, or really is not necessary to do after you've done your lateral grouting. Quality control is probably one of the most important processes of any grouting procedure. Inspectors should be trained. That's something that we're seeing in the marketplace, and there's some interest in growing interest, as we just mentioned, of chemical grouting in the industry. Next critical step is to train inspectors so they know what to look for, and I would recommend attendance in a regional grout school and/or training course to get some more information on chemical grouting. Warranty testing should be required and should be completed. Typically, it consists of retesting a percent of joints a year after sealing. So, in a typical specification for test and seal operations, just before the warranty is expired, the contractor should return and do a certain percentage of joints and retest those to make sure that the seal is maintained. And then there's guidelines detailed within the specification as to do if they do find an occasional joint that is not currently sealed. This specification is available at sewergrouting.com and also through the NASCO website. And it's also available in Word format for NASCO members. So it's a PDF, but if you're looking for that in Word format and you're not a member of NASCO, I'd recommend you. That's a small membership fee. You can get access to that Word document, and you can make changes in that specification and easily incorporate it into your standard specifications for your company and or your community. And with that, we're going to do an open forum of questions. We're going to get everybody involved that's been involved so far, so Ed and Dick and Mark and Daniel. We're going to go ahead and come up with a few of the questions that have been launched here by the audience, and we'll tackle those for a few minutes before our close. I think we've got just a couple minutes to be able to target those. So one of the overwhelming questions that's been coming through is costs. What does it cost to do a typical grouting project? So I'll tackle that quickly since I'm part of the audience here. Typical grouting process of an 8-inch pipe is going to run you anywhere from $7 to $10 a linear foot as a budgetary number. If you're doing test and seal, your grouting service connection is going to run you from $300 to $500 per lateral, and manholes will typically run you $500 to $1,000 a manhole. And those are all determined by the marketplace, what the current wage requirements are, and the type of pipe and construction. But those are some good ballpark estimates. A couple other questions we can hit real quick. Should laterals be brushed prior to grouting? Why don't you tackle that one, Mark?
Absolutely. Fully reinstated and brushed, or we will get nicks and cuts at the base of the lateral, and we're going to lose a lot of time trying to bring those back and reinstalling them on it. So definitely fully reopened and brushed.
And another one for you real quickly, Mark. How far up the lateral can a packer launch?
The answer to that question resides in how far can you inspect and clean, basically, and the configuration of the laterals. If we're going to tee off in two different directions, et cetera, we're going to do a common branch. Longest that's been done in the field is a 38-foot bladder to effectively seal 30 feet. This job was pre-inspected camera-wise and pre-cleaned to determine if this was the appropriate technology and length, and it was.
Good. Quick question for you, Daniel. There's a lot of different additives that can be added to chemical grout. Is there one that can be used for roots? And if so, what is its effectiveness in root control?
Yeah, good question. There are probably 5 or 6 different additives. Before you do a grouting project, you want to clean the roots out. We recommend a chemical root control program. So once that's done, you can add diclofenac to the grout batch itself. And what it does is prevent future root growth for about 2 to 3 years. And that should give the roots long enough time to seek a source of nutrients elsewhere and not go into the sewer. And real quick, on the last question, John, if I may, we've given a rule of thumb for how much grout to pump from main lines. I don't know if we have for laterals. If I have, forgive me, but on the question about laterals and why didn't it last long enough, Mark, is this correct? A rule of thumb for laterals is 2 gallons per joint connection and 1 gallon per foot up the lateral. Is that right?
Typically, we're looking at a connection being about 3 gallons of grout, and I've seen typically, and we're looking at about 1 gallon per vertical foot from the connection.
Okay, cool. Thank you.
Good points, Bio. We have got a lot of questions here, and we're going to run out of time to answer all those. We just spoke internally here. We're going to post the answers to these questions on the ICGA website and then as well through WEF. So we should be able to connect you with the answers to your individual questions. I apologize we weren't able to handle all of them. I probably got about 30 questions still sitting here to be fielded, but we've plumb run out of time. So at this point, I'm going to turn it over to Ted DeBoda with NASCO. He'll close the presentation out, but I appreciate everyone's participation. And please listen closely to the message Ted has to share at the next, as the next speaker.
Okay, thanks, John. And thanks to everyone, particularly those of you that are anxious to know more about chemical grout. I'd like to take a few minutes to talk about the ICGA with the hopes that you'll continue to use the resources that they provide, but that you might even have a desire to get involved in the association. Like John said, we'll probably collecting all the questions and getting them answered, and posting frequently asked questions or FAQ section on probably both the NASCO and the ICGA website. So we'll talk more about that. The ICGA, I mentioned the mission to support and promote the proper use of chemical grouting as a safe, economical, and effective means to reduce groundwater infiltration into the sewer collection system. Now, since ICGA is a division of NASCO, I want to briefly talk about NASCO for a moment to help you understand where ICGA fits in. ICGA, like WEF and like NASCO, is a nonprofit organization. For 35 years, NASCO has been committed to setting industry standards really to assure the continued acceptance and growth and success of all of us on this call, everyone in this industry. And to accomplish this, really our primary goals, our main contributions to accomplish our goals have been technical resources, training and educational opportunities, and other services such as industry advocacy and networking opportunities. Some of the resources include performance specifications. A perfect example is the chemical grouting specification that John described. That's available on both the NASCO and the ICGA websites. But we also have these same types of specifications for cured-in-place lining, for manhole rehabilitation, and a lot of others. So I hope you'll look at our website and see this stuff that's actually free to any members or non-members of NASCO, although membership allows you to download the actual Word documents to really make these documents your own. We also are pretty much a clearinghouse on manufacturer specifications. As an example, the types of grouts that we've discussed here, in addition to things like manufacturer specification for manhole lining systems, coatings, manufacturer-specific software specifications, and lots of other manufacturer specifications. We also have a lot of technical manuals available, the Trenches Assessment Guide for Rehabilitation, TAG-R, for example, Jetter Code of Practice for those that want information on cleaning lines. We've actually recently, about a year or so ago, released a video on jetter training. And then one of the probably least used resources, we have technical assistance. Jerry Munchmeyer is our technical director with over 40 years of experience in the trenchless industry. As well as with him, with our full-time staff, we can usually field a lot of questions that we get from consultants and municipalities, and I hope you'll send them in to us. But we also have a pretty wide network of technical leaders in the industry that we hope that you'll take advantage of. Two of the training programs that we provide, PACP, Pipeline Assessment Certification Program, really has become an industry standard for coding and assessing defects and observations in pipelines. You've heard reference to some of those codes in this presentation. Since 2002, we've trained over 15,000 users in the U.S., Canada, and South America. We also, the ICCP program, Inspector Training and Certification Program, trains inspectors and engineers in some of those unique requirements for inspection of trenchless technologies. We have separate classes for CIPP and manhole rehabilitation. And we also provide seminars and educational opportunities at forums like the Pumper Show, our annual conference, WEF conferences, both local and national. Plus, we provide webcasts such as these. We just had a recent webcast about inspection of trenchless technologies, which actually is available on our website on the homepage, as this webcast will actually be. So there's a lot of exciting training opportunities. This is, I'm not going to read this off, but it's a list of technical committees that really offer a lot to the industries in the specific areas of expertise. Look at our website, www.nasco.org, for more information on each committee, but also contacts you can make to get involved in these committees. These are just our administrative committees, like every organization like ours has. And that brings us to our divisions. Divisions are a little more autonomous than our committees, and I'm proud to say they're still part of NASCO, one being IPBA, the International Pipe Bursting Association, and ICGA, the Infiltration Control Grouting Association. The success of projects to control infiltration through chemical grouting was really one of the earliest goals of NASCO, if you can believe that. The ICGA was formed early on to take on this challenge, and it's been serving the industry really faithfully for years. One of their most valuable resources is their website, which really serves as a vehicle to offer their services to the industry. You can find schedules for training that's offered by their membership, links to specifications like the one that was discussed today, and technical resources like white papers and magazine articles. Probably one of the most important resources is the ICGA members themselves. These are the people responsible for putting this webcast together, and I hope you'll consider them as technical resources. You'll find their contact information also on the ICGA website. We mentioned these specifications before, but it deserves mention that this specification, like John said, was the result of a huge amount of coordination, cooperation, extensive peer review between industry professionals who kind of dropped their competitiveness and came together to provide you and everyone in the industry with a document that we believe provides the best opportunity for a successful project. One of the better-known training programs provided by the ICGA includes the Grouting Boot Camp, provided by members of the ICGA. It provides hands-on experience and hands-on training for operators and, frankly, also engineers and inspectors to perform the successful grouting operations. The last class was just a week ago, but look for upcoming classes listed on sewergrouting.com. There's also a class coming up on Sunday of WEFTEC, October 6th, that's going to be conducted at the WEFTEC Host Hotel, the Chicago Hilton on the 8th floor. This is some information on the slide you see now, and you'll also find additional information on sewergrouting.com, the ICGA website. So finally, we hope to see you at booth 461 at WEFTEC. That's where the NASCO booth, where we'll be located with the famous sewer history exhibit. And I got to say, I hope this webinar was really valuable to helping you control infiltration and extending the life of the sewers that you're involved with. We also sincerely hope that you'll take advantage of all the resources I've presented here and consider membership in NASCO and the ICGA to help improve the success rate of everyone involved in the pipeline rehabilitation industry. If we win projects, when we do successful projects, and we all win. So as the Executive Director at NASCO, I'm really proud to have the ICGA as one of our divisions and the work that they do to help this industry. So we'll see you all at WEFTEC, and thanks for joining.
Great. Thank you so much, Ted. I really appreciate NASCO and ICGA's sponsorship of this webcast because it allows us to offer the no-charge webcast to the attendees. And John wasn't kidding. We have over 60 unanswered questions. So we'll try to respond to all those questions, and I will post the responses on the FCP site and, as Ted said, the ICGA website. You can access the FCP site. It's www.westnet.org/chemical grouting. That's where you can find the presentation handouts and the PDH instructions as well. So if you have any other questions, you can email me at webcast with an S at wef.org. Thank you so much for joining today, and I'll see you on the next webcast. Bye.
The organizer has ended the session, and this call will be disconnected. Goodbye.